Hi, so a few of you have asked for a worked solution for the big M question that I put up. So here you go. I'm not going to work through the whole thing because I think it would take about 45 minutes on a video, but I've got my worked solution. I'll talk you through how I did it, and you can pause it at each table to check that you've got the right numbers. So here's the original problem. I've adapted my objective function, so I've taken away this massive number M, lots of the sum of my artificial variables. I've adapted my constraints, so I've got S1, S2, S3 and S4, A1 and A2, and then rearranged to get A1 and A2 as the subject, found the sum of them, substituted it into this here, and then rearranged, grouped them together, so I've got the coefficients of x, y and so on here, and then taken it all over to the left hand side. So that's my objective function, and those are my constraints. So they're the things that I'm going to put into my initial Tableau. So you can pause it there if you want to look at those a bit more. Now here is my initial Tableau. So this top one up here. So I've got everything in there. Once I've got my numbers in, I'm ready to start the first iteration. So this one is the most negative because M is a really big number, so that would be the most negative. And then I've worked out my ratios over here, and that is the smallest positive one. So that one there is my pivot element. So then I've gone on to do my row operations. So I'll read these out because they are quite small. My row operations are row 1, take away 2 lots of row 4, row 2, row 3, take away row 4, row 4, and the bottom one, which I think is where people are getting stuck, it's row 5 plus 1 plus 2m lots of row 4. Okay, because I want to make that 0, so I'd want 1 plus 2m lots of that added on. So I'll leave, you can pause it there if you want to take a look at those numbers and check that you get the right things. I've done a little bit of working out there, just but the final answers are these ones here. So then once you've got the second tableau, you go through again. That's the most negative column. Worked out my values of theta. This one here is the smallest positive, so that 1 is my pivot element. So again, I've gone through and I've got my row operations. So I'll read them out again for you because again, they're small. So row 1, take away row 2, row 2, row 3, take away row 2, row 4, and row 5 plus 2 plus m lots of row 2. Okay, so you can pause it there and check that you can get the numbers that I've got, or the expressions that I've got in my table. And then once you're okay with that, you can have a go at the next iteration on your own. So again, I've found the most negative is the Z column here. Worked out my ratios, that's the smallest positive. That's my pivot element, so the S3 becomes a Z. And this is my fourth tableau here. So my row operations are row 1, take away 5 lots of row 3, row 2 plus row 3, row 3, row 4, and row 5 plus 3 plus m lots of row 4. So once you do the fourth tableau, so I'll let you pause it there if you want to just check that you can get to those numbers yourself. We've got to a point where the artificial variables are non-basic, so they're not negative. We've also got no m's here, which is really nice. And that means because these are non-basic, I can cross them out. Okay, so we can reduce our table now. So we've minimized are artificial variables, and therefore if we go back to our objective function, we've minimised this part here, so it's now 0. So that's great. Okay, and we're just left with our original objective function. So if we go and cross out this column and this column, and we actually only need to do one more iteration here. Okay, we end up with this. So this is our last one. So my row operations are row 1 divided by row 5, row 2 plus row 1, row 3 plus row 1, row 4 and row 5 plus 3 lots of row 1. So check that you can get to those. And then because there are no negatives in the objective row, the table is optimal. And then my final solution is S3 is 12, Y is 18, Z is 16, X is 4, and the maximum value of P is 56. Okay, so an exam question won't get you to do the whole thing because it will take the whole time of the exam. They'll either just get you to interpret the end tableau maybe, or just get you to do one iteration, or maybe to say, they might get you to do an iteration and say why if you can't reduce it, if you can't get it, so these are positive, then it doesn't have a feasible solution. They might get you to interpret that, but they won't actually get you to do the whole extensive problem. So it won't take that long in the exam. Right. Get in touch if you're still not sure, because it is quite a long-winded, messy method. So give me a shout if you need some help.